Distracted. Okay. So,
I heard that too.
it's hardly ever that I teach this concept that I don't have somebody that runs into like cosine of 30 plus 60. And they don't try to go, oh, that's cosine 30 plus cosine 60.
Yeah.
Okay, that hardly ever works. Like for instance, if you have the logarithm of x plus y, or the square root of x plus y, that is not equal to the logarithm of x plus the logarithm of y. This is not equal to the square root of x plus the square root of y. I even have some of my AP Calculus BC students every now and then say that's x plus y. No, it's not, okay?
And this is why I'm failing the ACT.
Well, ACT's coming up
It's
this
close
weekend,
to
I
home.
think, so
I'm
listen,
taking it.
okay, listen, what I say, I hope will help you with it. Because you see it in some of your studying. It's all about what a composite function is. Right now, really, the only thing you can distribute until you get to, well, we'll do a little bit in pre-cal, but it was the distributed property of multiplication, but somewhere along the way, your teacher quit saying the distributed property of multiplication, and they would just say distribute. So that is 3x plus 3y. That is equal to, okay? But then what happens with students, they're like, oh, I love the distributed property, why don't I just distribute everything? And you can hardly distribute anything because it's a composite function. Like if you think about why this wouldn't work, that would not be the cosine of 30 plus the cosine of 60 because that's not what you're being asked to do. You're being asked to add these together before you even do an operation to it. Do y'all see what I mean? So you don't even have the distributive property of addition. You just have the distributive property of multiplication. If I have 3 plus 2 plus 5, I don't say 3 plus 2 and 3 plus 5. I would get too much, wouldn't I? Doesn't that arithmetically tell me to add the 2 and 5 and then just add 3 to it? Don't add 3 to both of them, you'll mess it up. All right, so what about what about this? What about the square root of 16 plus 49? Y'all can easily see that's not equal to 4 plus 7. Because the whole point is they don't want you to take the square root of 16 and the square root of 49. That's not what's being asked of you. Do you see they want the square root of 65?
Yes.
No one's asking you to take the square root of, but you see how tempting it is, especially when it's written this way. I've said this to you in this class before, I think that is like super glue. Those are stuck together, okay? You gotta add those first, PEMDAS, before you do anything else, all right? So when I'm being asked, do y'all see how vastly different the cosine of 30 is like way down here, adjacent over hypotenuse. The cosine of 60 actually has nothing to do with the cosine of 90. 90 is just straight up. Do you see how there'd be a cosine of 30 and a cosine of 60? It doesn't make sense, but our brains want to do it, don't they?
Yes.
My brain wants to go cosine of 30 plus cosine of 60, but I can easily see that's not at all what's being asked, okay? A good example of this in, I don't know why I just go to another slide. Anyway, a good example of this is like cosine of 60 and cosine of 300 are the exact same number. They're both 1/2. And so it's all about where your angle lands. You could easily justifiably say, well, whoever cares what cosine of A plus B is, but it matters a lot in different applications, and it even builds into something that I use a lot in calculus. So anyway, and I haven't shown you why in the world this happens. Like I would go, how in the world would somebody have thought to go cosine A, okay, time out. Suppose that we're all bright enough, not suppose, we're all bright enough to grasp now that I don't need to be saying cosine of A plus a cosine of B. That is not what's being asked of me. Did y'all get that? Okay? But I also wouldn't have gone, okay, I get that, but I would have not ever thought, well, you know what, let me try this. Cosine A, cosine B minus sine A, sine B. I bet that'll work. That'd be next to crazy, wouldn't it? So somebody has proven why this works. It has to do with similar triangles and everything. I could have proven it by now, I don't know why I haven't. But anyway, you have cosine A, cosine B, minus sine A, sine B. Let's take one that we can verify. And this will answer your question, Julia. Cosine 300, suppose you just forgot it. Everything about 60-degree angles, and all you could remember was your 30-degree angle column. Okay? So I could make this the cosine of 330 minus 30. And then all I have is my 30-degree column. Do y'all see those are 30-degree reference angles? So you'd have to come up with two things that you've heard of before that add, like on your later problems on the worksheet that I'll give you a chance to ask questions. Cosine's always, by the way, kind of the weird one, okay? And we'll talk about that as we go, because there'll be some things we write on our memo page. I know the identity, you'll be memorizing it. Cosine A minus B goes cosine A, cosine B, and ironically it goes plus sine A, sine B. And again, that's from people like derived it just like other things I've shown you. Cosine of 330, if that was on your memo page, it's in the fourth quadrant, it would be positive square root of 3 over 2. Cosine of 30 in the first quadrant is also square root of 3 over 2. Sine of 330 is negative 1/2, and sine of 30 is positive 1/2. Multiplying fractions, I get square root of 3 times square root of 3, which is square root of 9, which is just 3. So this is 3 over 4, 2 times 2, plus a negative or minus 1 over 4, which gives me 2 over 4, which gives me what? 1/2. Which of course you should know, right? The cosine of 300 is a 60-degree angle. So just because I did one doesn't mean that it always works, but I'm just showing you it does work, okay? I'm not a proponent of you having to figure out the cosine of 300 that way. Hopefully you know your 60-degree angles. But on your sheet, you probably ran, why don't I just go to another slide? On your sheet, I'm gonna put this up in this corner and then I'll mess you up. Okay. What y'all have a cosine, I'm so sorry, 165, what have I, what on the second page?
Yeah, 165.
Okay, cosine or sine?
Either.
Okay, she had both. All right, so cosine of now I'm going to show y'all some really cool shortcuts here too. That ironically would make your second page go a lot faster. That you're probably mad that I didn't show you at first, but I wouldn't really show until you've played around with these what I'm going to show you today. But I'll pull back on my slides later and show you some. What you needed to do was come up with two things that you know. Did anybody do that?
Yeah.
Yes.
What'd you
I
get?
watched your video.
Megan? Oh, sorry.
135 plus 38.
All right,
I
so
did that as well.
Yeah.
you could do cosine of 135 plus 30. Did anybody do another one? What'd you do?
Cos 120 to cos 45.
All right, but you don't distribute it.
Yeah, no.
So you mean cosine of 120 plus 45?
Yes.
Okay.
I didn't know how to do it, so I chose 3 numbers, but I don't think that's allowed.
I don't know what in the world I would do with 3 numbers.
Yeah, exactly.
So are you okay with one of these?
Is though in cosine.
So Alex in Nazareth did 120 and 45. Some of you others did 135 and 30. Should we all get the same answer?
Yeah.
Yes.
It'll look a little different till the end. Those of you that really did your homework, I say that a lot, I mean capital really, you just weren't trying to knock it out. You're at a place in life where you really have to think about what you're doing. You capital REALLY, like you actually really thought about your homework. By the time you've done a few of them, you realize, you know what, if I forget this on the test, I'm just gonna say square root of 6 minus square root of 2.
Yeah.
I'm gonna write something like that down and hope for the best, okay? All right, but haven't you noticed that in your 1, 2, 3 chart? That's how they're repetitive. There's gonna be a really cool thing I'll show you about that can make the test go quicker for you and some of your homeworks. So anyway, this is cosine A plus B pattern that you looked at on the front of your page. So I'm gonna say cosine A, cosine B, and it goes minus sine A, sine B,
So I have a question.
okay?
I wrote it slightly differently where I wrote 30 first. Will that make a difference?
No, you would have cosine 30, cosine 135.
Mhm.
So do you see they're still multiplied
yeah,
together?
yeah, okay.
You have to think about your signs, so you would find the cosine of 135, which is negative root 2 over 2, 45-degree reference angle in the second quadrant. You need to be fast at those now. I hope you're not, I think you probably are still drawing your charts, but hopefully you just know these things. That's what my goal was.
Sine 30 is one I know by heart now.
Yeah, well that helps you know all the other ones in a way.
Yeah.
You know, like
but
if you know
sine
that's
30 is
one
the one that
half.
just keeps coming up.
Yeah.
One half.
Yes.
Yeah, and so then you know the cosine of 30 is not, and
Yeah.
the other option square root of 3 over 2. It may help you that way. Cosine of
Rule
30
out.
square root of 3 over 2. Sine of 135 in the second quadrant is positive root 2 over 2, and sine of 30 is 1/2. And I was skating through this really fast when Brent was asking a question last class. This is negative square root of 6 over 4 minus square root of 2 over 4.
And then you just have to write negative
So
6
you have negative square root of 6 minus square root of 2 over 4. You cannot say like the square root of 9 minus the square root of 4 is the square root of 5. Pause, girls, because I do it in class, obviously, and then on test, I'm still grading somebody that's called like the square root of 6 minus square root of 2, they call it square root of 4. And then they say, oh, square root of 4 is 2, and then they're finished with a problem that had a bunch of square roots in it that you couldn't work. All right, do y'all see that this is not the square root of 5? That's not what's happening there, okay? That would be 3 minus 2, that would be 1. But you can't subtract square roots, they're not like terms. So you're stuck with this.
Wait, I don't understand where you got 135 from.
You have to think of two things that you know to
No.
add to 165.
No, I know, but I don't get how you got what makes 135.
All right, name some others for me.
All students take calculus that chart.
No, time out. Let me talk
135
to her. Hang on just a minute. Hang on. Let me just have a teaching
No,
moment
so
here.
I know that
All right.
135 plus 30 equals
Wait a
65.
minute. Time out. Okay. Pause.
Okay.
Okay. So can you think of any others? Don't help her.
This is
So-
like my worst nightmare. I just can't do it.
Okay. That adds up to 165, and I have a shot at knowing those because it's a 45 and a 30. Like I can find the cosine of 135. Like I'm not going to use 165. I don't know anything about 100 or 65. You have to come up with two that have reference angles that you could pull off.
Oh, so you use 90 and 45 to do the 135?
Yeah, you could
Oh,
do
well,
that.
that's what I got.
Okay, but I know 135, so hopefully I wouldn't have to do that. But if I forgot 135, I could use 90 and 45.
Okay.
So let me backtrack. Hang on just a minute. Suppose you're sitting on the test and you forgot the sign of 135. Like you totally forgot how to do it in the 45-degree angle in the second quadrant. You could use 90 and 45, which I hope you wouldn't have to do, but that would get you the right answer of the sine or cosine of that. Okay? But what's going to happen is, let me give you ones I don't know. Like I don't know the sine or cosine of 165, so it's on you, which is why I'm making Anya do it. And you can think along with her if you don't get what I'm doing, because a couple other people have had the same question, Anya. I want you to do it all by yourself. Think of two angles that add up to 165 that you can figure out something about, that have a reference angle that you know. Will 110 work? 110 and 55. I know nothing about those angles. All right, so go.
You do 105 and 60.
Close, but I don't know 105. Very good. That's on the right train of thought.
165.
I already ruled that one out. I don't know 65.
Can you do 180 minus something? Maybe?
You could, but it'd be 15, and I don't know
Yeah.
15.
I don't know.
Keep thinking.
What about 90?
No.
We're not using 90? Or she can't tell me?
She took both, but you're not gonna know 90 and 75 doesn't help me. 90 helps me, 75 doesn't. So let's start from 0. I don't want 0 and 165. What's the next one you know? The next reference angle you know?
30?
30 and 135. We already used that one. It works. That's fine. But suppose you didn't think of that one. What's the next one you know?
61.
That's not the next one you know.
Oh, 45?
45. Do you know 120?
Yeah.
Because it's a 60-degree referencing.
Oh, okay.
Okay, and obviously if you're doing your homework, I can only ask you so many that are some combo of something you've done before.
Okay.
Okay?
That's how, yes.
I'm sorry I forced that on you, but
It's okay.
I knew you would understand it if I kept on.
I get it.
And it goes a lot quicker than it sounds.
I just didn't
once you
understand why
see
it had
it,
to be like
yeah.
that sort of number without
And
it.
a student could have, some people in here worked it with this one and got the same answer. Okay?
That makes sense.
And you can subtract. I probably could have come up with something. I think I could do 225 minus 60, and you'd still get the same answer. Okay?
Okay.
Alright, Alex?
So you just said that you have to think of the 60-degree angle when you're doing the 120. I did the 30. Is that okay? Because it's like
Don't ever go from 120 to 90, ever.
no. Oh no, to like 30 as like using the 1/2.
If you had 60, if you had 120, you must be using 60.
Okay, and same for
Butterfly, bow tie, it shouldn't even have worked out correctly. You should not have gotten this answer. Did you get that answer? Okay, let's do it. So you used 120 and 45?
yeah.
Okay. All right, so good question, Alex. This is what Alex and I think we're talking about. If I go to 120, I don't ever want to count this way. I'll start missing my problem. You've always got to think of what your reference angles that we learned, like one of the first classes we ever had, bow tie, butterfly. So when you go to 120, you always count to the closest x-axis. So we're going to do it with 120 and 45. All right, that's cosine A plus B, so I'm going to go cosine, same problem, cosine A, cosine B, plus sine A, I just did that wrong, I'm going to correct it, sine B. All right, my incorrect thing, cosine's plus ends up being minus. Okay? I'm sorry, let me pause. They found from their proof that cosine A plus B goes cosine A, cosine B minus sine A, sine B. Okay? Cosine of 120 is a 60-degree reference angle. It's a 60-degree reference angle in the second quadrant. Cosine of a 60-degree reference angle in the second quadrant is negative 1/2. The cosine of 45 is root 2 over 2. The sine of 120 is positive root 3 over 2. It's a 60-degree reference angle. And the sine of 45 is square root of 2 over 2. So you get negative root 2 minus root 6 over 4, which is what we had on the other slide for the people that use 30 and 45. So if you were accidentally incorrectly using a 30-degree reference angle, yours wouldn't have both been negative. One of yours would have been positive.
Okay.
So I'm glad you brought that up. When you go into a quadrant, always go to the x-axis. It's very dangerous. Everything, all your numbers would switch around in your 1, 2, 3 chart. Okay? Okay, so let's back up and let's give the answers to the worksheet. But before we do that, let's talk about the identities at the top and let's write them on your memo page. Don't write them yet, but go on and locate your memo page.
Is it always going to be root 6 and root 2 in the answers?
On the sine and cosine ones, most likely. I'm trying to think if there's a case I haven't seen that.
It's weird.
Okay. Well, it's,
It just works that way.
well, you see a lot of one half skirt of the
Yeah.
These are all 15 and 75 degree reference angles.
Yeah. You have a very good chance of guessing the answer.
Yeah. And if you think about what quadrant it's in, it can increase your chances. It just depends on how much you want to think.
Yeah.
I'll show you some cool stuff you'll like, Kate. All right, I still am regretting that I haven't shown you where this came from yet because I think it would make more sense. So maybe next class I'll show you like actually how in the world they knew this because I wouldn't have ever known it, okay? It's just like if you couldn't solve a quadratic equation, can you imagine somebody going, hey, why don't we try negative b plus or minus square root of b squared minus 4ac over 2a? I bet that'll work. Why would they have thought of that unless somebody had proven it would work before? Do y'all see what I mean?
Yeah.
So crazy equation, somebody has proven that it will work every time. All right, so these are sum and difference identities. Easy to remember the name. Sine and tangent, sines do S-I-G and S. They do what you think they should do. Let me pause for a minute. There's something else we're gonna add to your memo page that you don't know yet, so I need to stop there first. So memo page is out, okay? Don't write on it yet. Your clue that write on it is I will box it in and I will step aside. But y'all, right now I don't want you writing because I want you listening, okay? Is everybody watching? You're not writing. You'll have a chance to write in a minute, okay? These are called the negative angle identities. Sine of negative theta equals negative sine theta. And before you think that I just pulled that negative out, I did not. That wouldn't make any sense. Tell me if you see this on the exam in the true false. If you would say true or false. Kate's right, it's false. First of all, that shouldn't work if she's thinking PEMDAS. One of them asks you to double an angle and take the sine of it. The other one's asking you to take the sine of an angle and double the fraction. Those are two different things. Do y'all see this is actually asking you to double the ratio? Also, I have no business I couldn't do this either, could I? You can't start like pulling things out of mathematical expressions. Does that make sense? Also, another thing that you can think about, I don't know if anybody thought about it, I'd love to think you did. This affects the period of the graph. It makes it go this way. Doesn't that change the period? What does this change? You're comparing apples and oranges. Do y'all see what I mean?
Yeah.
So I did not pull that negative out. All I'm doing is writing down a fact that I'm going to show you how they know later. But a big, big deal, okay? By the way, a lot of us don't like going in the negative direction. So if I ask you for the sine of negative 150 sometime, which you've done before, you've gone negative 150, 30-degree reference angle, but you could just take the sine of 150 and take the negative of that if you like it better. Do y'all see what I mean? All right, now I'm going to write tangent of negative theta equals negative tangent theta. And I'm only writing that because it's true, okay? But cosine of negative theta, you've heard me say this a couple of times today, but it hasn't meant a whole lot to you because you haven't seen a whole lot of the rest of the identities. Cosine's always kind of weird, okay? Cosine of negative theta equals cosine of theta. So obviously I'm writing down math facts. I'm not pulling out a negative that I should not pull out. Everybody listen to me. Don't do it, but if you got out your calculators and I asked Ava to type in cosine of negative 300 and Mia to type in cosine of positive 300, they get the exact same thing. If I ask Alina to type in the cosine of negative 8,428 and Brenda to type in positive 8,428, guess what would happen? Same number. Okay, it doesn't matter which way you wrap around with cosine. Let me show you what's happening, which is why you're not writing. Y'all know all students take calculus, okay? And before I do that, let me show you this. If I told you to go 100 degrees, wouldn't you go like this? What if I tell you to go negative 100? okay? What if I tell you to go 30 degrees and then negative 30 degrees?
Yeah.
Okay.
The bow tie.
And so, well, that's not really what I want you to see at this point. Do you see if you wrap around 100 degrees one way and negative 100, or whichever I tell you, they end up in quadrants below each other, above and below each other? Okay, let's do one more. Suppose that in blue I do 300. 300 would be right here. Where's negative 300? So do you see what I mean? If I have a positive and a negative, don't they land above each other? Y'all don't seem to agree. Are y'all okay with that? Okay.
Yes.
Let's look at sign. Okay, I know that's hard to read, but I'm talking about sign. All students take calculus. That's what sign does. Also look at the graph. Doesn't sign go positive, positive, negative, negative?
Yeah.
1, 2, 3, 4. Okay. Look at what happens. Girls, watch. If you go this way, you get a positive. If you go this way, you get the opposite. That's what this is telling you. If you wrap around different clockwise or counterclockwise, you'll get the opposite of what you got the other way. Do y'all see that?
Yeah.
So look what happens if you land in quadrants above each other. Tangent goes like this. Tangent goes positive here and negative here. If I graph it, it actually does that. It comes at me like this. Okay? Doesn't it go positive, negative, positive, and then negative? Do y'all see how it's doing that? Okay, now, what happens if you go clockwise and counterclockwise? You don't get, I couldn't say this. I can't say, oh, I don't care which way you go. You get the same answer. I don't care which way you go, but you get what answers? Do you see how I'm telling you get opposite answers? Y'all see what I mean?
Yeah.
So if I go over here and get a tangent, and I go down here and get a tangent, they'll be the same number because of the reference angle, but they'll have different signs. One will be positive and one will be negative. Let's look at cosine. All students take calculus. This is what calculus, that's what cosine does, right? Does it matter which way you wrap? I don't care if you go to 100 or to negative 100. Won't you get the same exact answer?
Yeah.
They have the same sign. That's what this thing is saying. Okay? By the way, girls, cosine does this. Positive, negative, negative, positive. Positive, negative, negative, positive. One more thing that's real important here. I'll draw on the cat because this is something that you know, so it's not super important that this is going to be, I don't really care about the distraction a whole lot. Cosine, would y'all agree an unaltered, unshifted cosine looks like this? Okay? That is evenly distributed. It doesn't matter if I go this way or this way. It's what you called in algebra an even graph. So that's why cosine of, watch, theta is the same thing as cosine of negative theta. Wouldn't cosine of 3 pi over 4 be the same answer as the cosine of, I don't care which way I go. Does it matter which way I go? But look at sine. Y'all know sine goes right through there, through the target, okay? And if I go this way, I get this answer. If I go this way, don't I get that same answer, but I get its what? They're opposites of each other, aren't they?
Yes.
Like look over here and over here. Aren't those opposites of each other? That's what you called in algebra class an odd graph. That means I don't care if you go opposite directions, fine, but you'll get different answers. Opposite directions give you opposite answers. And with tangent. If I go this direction, I get this answer. If I go this direction, I get the same answer, but I get the negative. Doesn't this come through right here? Okay, so that's why I wrote this on the board. New identities that you'll deal with. These will not be, if you have a memo quiz next class, this will not be on the memo quiz yet. I'll let you know when it's going to be there. So what would I tell you if you run into a negative angle? Negative angle identities. Okay.
Oh.
We have sine.
Are you okay?
Sine of negative theta and sine of theta are not equal to each other, they're opposites of each other. Tangent of negative theta and tangent of theta are not equal to each other, they're opposites. But with cosine, what did you see? With cosine, it didn't matter which way I went, I got the same answer. They're equal, okay? That means this one is odd, this one is even, and this one is odd. Okay, you can write them down. Negative angle identities. Sine and tangent are odd graphs. They're symmetric to the origin. Cosine is an even graph. It's symmetric to the y-axis. You okay, Nazra?
Yeah.
You okay? Sorry, I was all wrapped up in my proof there.
Oh, no, it's fine.
My memo page is getting really tight.
Yeah, I'm running out of room.
I'll make a new one and pack it together so I already know all this stuff.
I have a completed one of
Mine's like
Katie
two.
Lapola's. I reposted on the website. The last one I had was Rachel Geiger, who I taught a long time ago, 7 years ago, who went to Duke, but she's out of college now. So I've replaced it with a Marymount memo page. If you want to look how Katie spaced her stuff, it's under topics. If it helps you with your
Do we
spacing.
have all the same stuff as them, or do they have more than us?
We're almost completed. Theirs is completed in ours. Hey girls, I hope you would agree that a whole lot of reasons I make you do a memo page. Hopefully you've memorized it. You look at it enough to where you don't have to look at it anymore. But it's a great study skill, even if I don't make you do something like this for the next unit on whatever we go to next, sequences and series. It's kind of a good idea to kind of keep a running page of important facts in a central location.
Also, I think it's helpful that we did it in, like, not all of it at the same time, but like
Yeah,
little by
you're
little.
building it.
So like you spend like a week or something memorizing one thing, and then once you already got that, then you add something else, and it's
That's
like,
why a lot of teachers, in fact, Relina just had a hands-on one that someone gave me. They're like, oh, you can give this to your students. It was a list of all the identities. But I would much rather you write them in your own handwriting
Yeah.
and explain it to you.
I think Miss Arkansas
Mr.
does
Hill's
that.
class gets really up in arms about our memo pages.
Why do they care?
Because they just recently gave them a test and they were all, I'm not even in the class, obviously, but they were all complaining. They're like, Mr. Hill didn't give us enough time. And Lazari's class, like, they all do so well. And we're like, yeah, we have our memo pages.
It's actually the same test.
Yeah,
But he let
I
me
heard.
omit one, and I didn't. But I wrote that test this time.
Yeah,
And sometimes he writes the test
Yeah.
though. So it kind of comes out in the
yeah,
wash.
they were being really
Do
angry.
you and Miss Arkansas ever have the same tests?
Yeah, we're working on the pre-cal test together, pre-cal exam. But, we all watch out for, he changed some of his because we emphasized different things.
Yeah.
Yeah.
So our first 3 questions were completely different
Mhm.
because of the way I emphasized something over his. So we share, because we want it to be fair, but we can tweak it for our class.
Yeah.
Yeah.
Which I will definitely do with your exam and same with Miss Arcan. Okay, so also, let's get the sum and difference identities on your memo page. It was unusual for me to hand you identities without proving them or giving them to you first. But I knew that I didn't have time in class to get over them very well, and I wanted you to have something to look at. So don't write them down yet, but in your own please don't write them down because I'm going to shortcut it for you. Okay? Girls, you're going to learn a new notation most likely, but don't write anything. I always am afraid a tour's going to come by when I'm like, stop writing now, don't take notes, okay? But you'll see why in just a minute. I'm going to do sine of A.
We get it.
No, I really should know.
And this is our.
Okay, got it. You made me so proud. You made me so proud.
Thank you.
It's
It's really hard though.
like, yeah.
It's like too hard.
Imagine being good at English. Like I could never.
Yeah.
What? But like I mean like in like
I think your Hamlet
You
essay
kidding
is
me?
really good.
no, but like I mean like imagine just like reading something and you're like, this is the meaning behind the poem.
No one
I do
understands
that.
poems.
You do.
No,
know
I
you
do.
I like poetry and plays. That's about it.
Sonnets, nothing could be more confusing.
I love sonnet.
Imagine
That's like the only thing
I
I
just
love.
want
Two
to
brain
boy.
cells.
If a boy
Just
wrote me a
one.
sonnet, I'd be all over that. But like, I don't. I just don't understand.
It's just like a
that.
different
She's
like
being
type.
Okay, everybody be quiet and listen. Thank you for not writing and just being patient. This is one of those things where I wanna go, do you see what I did there?
Oh,
Okay? I condensed it to where it's, well, I'll write down 6 if they're all just alike. But also you learned a new notation you might see in future math books sometime. And do you see how you follow the thread through there? So what does this one mean? If you have cosine A plus B, you follow the top.
Negative, yeah.
If you have cosine A minus B, you follow the bottom. So look what happens with tangent. What's tangent A plus B? Say it out loud to me. What would you
Tangent
say?
A plus B
equals tangent A plus tangent B over positive tangent.
Over negative.
Negative.
One
Over
minus
tangent A plus.
Okay, so what I'm trying to tell you is tangent A plus B equals tangent A plus tangent B over 1 minus, because they're all on the top. If you have tangent A minus B, then you would have a minus on the top, but a what on the bottom? A plus.
Plus minus minus plus.
So you can read it like it if you don't, or you can write all 6, it's up to you. All right, so get them on your memo page kind of quickly.
So
Some
many
and
other
different
friends.
identities. Oh my gosh, this is all I have.
I'm gonna hit the undo button for a minute, so that it's all blue. But let me know if you don't see how to read this. So it's kind of weird.
I feel like everyone would be happier with a memo page.
Same.
Oh yes, it makes you very happy.
You should copyright it.
Somebody already has, I mean, not mine, but they have these things called smart cards with like, I don't know.
But you know how like
I
at
tried
Barnes and
that with-
Noble you can like buy like the cheat sheets?
That's what I was talking
You should do
about.
that.
Yeah, they at first were called smart cards.
Yeah.
That should be your big idea. Like the
Yeah,
closing down
so forget the
memo
clothing
pages.
line and do memo pages.
That'd
Or
be
like
really
clothing that has an embroidered
Well, here's the deal,
on.
I've been here 6 years and even the Marymount faculty doesn't buy into it, so I don't think I can get anybody
Into what,
else.
the memo pages?
And the chart instead of the unit circle.
They're just
Why?
stuck in their
This
ways.
is so much
Yeah,
easier.
unit
It's
circle
way
sounds
easier.
horrible.
It really does.
I really
my
think-
ACT tutor is like, well, how did you
Here's
do
what
that
I would
so fast?"
argue, is that you do know the unit circle. Like when I say 120, you know right where that is, you're rotating around. Just why memorize everything if it's the
But
same
we know the
thing?
unit circle because we know this, so like I feel like we actually get the unit circle instead of like remembering like
What I say.
Another
Yeah.
one's so complicated, but this is just so simple to remember.
Because
everyone needs this.
It's so true.
I wonder though if you feel that
They
way, if you
deserve it.
had another, well, here's why I agree with you, because I taught it the other way for a few years until I started doing this, and I think it is better, but that's just me.
Well, a bunch of kids are like, oh my gosh, lucky like you have this.
Yeah.
I'm, like doing my math
They're
homework."
bitter about it.
What were you
Yeah, they
saying?
are.
I tried to teach Chili. I was like, what?
Mia, what did you say earlier? I kinda was
that my
talking.
ACT tutor is like, how did you find what that angle was so fast? And I was like, well, I
Yeah.
memorized it.
Because they probably use the unit circle.
Yeah, she showed me the unit circle and I was like, okay.
Yeah, my SAT teacher asked me if I knew the unit circle and I was like, actually I do something better. And she was like, oh wow.
She's like,
It's been out in books even for years, and I don't know why people fight it so much.
Yeah. I tried to teach and literally just the 1, 2, 3 chart. Like just the 1, 2, 3 chart. I tried to teach it to my boyfriend and he was like, stop talking. I don't get it. Just let me do the unit circle. And I was like, it's so good though. And his brother too was like having such a hard time with it. I was like, oh, just use this. And they were like, no.
Well, they're used to it.
I tried
You're
so
right.
hard. I tried so hard. And what do I get?
Notice the, were you the one that was gone? Do you notice the plus minuses up there?
Maybe you guys
we
could
got
do a
everyone. I'm like,
memo
yay!
Rachel,
And
why
I
did you do a
taught
memo
you this.
quiz?
So
And
that's
I
what
could have given you the 1, 2, 3 chart.
It's his like
You could have done a memo quiz, right?
So I'm trying to say like. on
Oh,
the-
I should do that. That is so
A
smart.
plus
Thank you
B
for that,
plus
Mia. I
minus
love that
and
idea.
A minus B
A memo
plus
quiz
C.
race with Mr. Lee
Just follow
Rosenthal.
the thread.
Yeah, do it.
Yeah.
I'll be like, who's gonna win?
Alright, Bryn.
Instead of him.
But it's
not-
accuracy
Yeah,
and
when you
time
talk.
also.
One day that's gonna be great on your own stage, but not right now.
Yeah, because I should do a memo quiz race and see who can finish it faster.
Yeah.
And be like,
So it's like the big
face.
guys.
I do plan on having some trig bees and bring in some like candy or something.
Can we do like all around the world? So, like,
Maybe, I don't know
It's
what
all
that
around the
is,
world.
but
I
I've
remember
gotta
that.
watch the time.
Yeah, we
Remember
did
we used to do that?
this
Yeah,
year.
Charlotte and Kennedy was like always
You know what was my
Like
nightmare
Cora.
as like when I was younger was minute math.
Oh,
I was like,
God.
this
I
is
know
it was like
that.
4 plus 3 and I was like, didn't we do minute math?
love that.
Girls,
I
I need these minutes, so stay with me, okay?
I did it last year.
On the next memo quiz, so far, we won't have the sum and difference or negative angle identities on it, okay? But you may have to use them in homework some. All right, so I'm gonna go to, number 1, sine of 15, on your worksheet. Sine of 15, you should have gotten square root of 6 minus square root of 2 over 4. Is that what you got?
Yes.
All right, and you don't have to memorize that. I just have done this a long time, okay? Cosine of 15, I had already done for you, so just look up. It's not number 2, but it was my example. And I got square root of 6 plus square root of 2 over 4. The reason I'm kind of rushing, as I was really rushing in the last class to tell you, you could do the tangent of 15 with the pattern. Or I'm okay if you use another identity and put sine of 15 over cosine of 15. I want everybody to listen big time. On the test on this, I'm not gonna ask you, please listen, I'm not gonna ask you for the tangent of anything like 15 or 75 or 165 without somewhere on your test already asking for the sine and cosine of it. Okay? Because watch this. Tan of 15 technically is haven't you just recently learned tangent is sine over cosine?
Yeah.
So I could put the sine of 15 over the cosine of 15.
That's what I tried to do, but I got so stuck.
Alright, hang on, Brian. Square root of 6 minus square root of 2 over 4. Keep change flip. And this cancels. My answer is square root of 6 minus square root of 2 over square root of 6 plus square root of 2. Let's just hold that for a minute, okay? If you use the identity, you got something that looks far different from that, okay? So most of y'all probably either did 45 minus 30 or 60 minus 45. Are there some nods there?
Yeah.
60 minus 45 is far easier than 45 minus 30. So now I'm going to get you to think, okay? Tangent of 30 is root 3 over 3. I'd rather not put that into a big new identity. Tangent of 60 is just root 3. It's easier if you can use 60. So while we're brainstorming, like Julia and Anya were asking at the beginning of class, like, what do I do for 15? I wouldn't mind if you did 45 minus 30, but your life's going to be a little bit harder with tangent. I'm going to do 60 minus 45. Please stay with me, girls. That's tangent A minus tangent B over 1 plus tangent A times tangent B. Alright, tangent of 60 is root 3. Tangent of 45 is 1. This is 1 plus. The tangent of 60 is square root of 3. This is times the tangent of 45, which is 1. So you multiply first and you get square root of 3. I'm sorry, this is a 3. Ooh, that's a 3. So my answer is square root of 3 minus 1 over 1 plus square root of 3. Now what if you walk out of the test and say, oh, look what I got for number 2. And your friend goes, oh my gosh, I got that for number 2. What happens if I type both of those answers into my calculator? I get the exact same answer. I will accept either one. I honestly, as a calculus teacher, girls, as a calculus teacher and beyond, like classes I took beyond that, I know that it's imperative that you know cosine A plus B, sine A plus B. It's not super important. I don't think in calculus I've ever run into tangent A plus B and tangent A minus B. But I honestly don't care if you memorize them. I'm not gonna put tan A plus B or tan A minus B on a memo page, okay? I mean on the quiz. They're on there in case you need them for another teacher. But if you like look through your test and you ran into tan of 65, somewhere on that test prior to that, I've made you find the sine of 65 and the cosine of 65, so you can find the tan of 65. By the way, I said 65 because I couldn't do that myself. I can't think of two things that add up. All right, now, one more thing before we go, because these were all degrees. Two more things. What time is it? Is it exact? Y'all probably some of y'all have a class, don't you?
Yeah.
Okay, so let me show you this, and then I'll show you the sneaky stuff next time. You'll have some more of this for homework, but you'll all of a sudden run into stuff like this. I'm going to start throwing some radians in there. I don't want you to convert to degrees. If you did, these would be like some of the ones you ran into, like 75s and 15s. Can I think of two things that add up to pi over 12?
Pi over
What about
4.
3 pi over 12? I'm sorry, let's subtract. 3 pi over 12 minus 2 pi over 12. How come I could do that one? Pi over 4 and pi over 6. Somebody else could do 4 pi over 12 minus 3 pi over 12. Because you know those. I wouldn't do 5 pi over 12 minus 4 pi over 12 because I can't reduce it. Do y'all see what you're doing?
Yes.
Okay. All right, so I'll post homework. I don't know how far I would get. And we still aren't going to have a quiz on verifying identities. I'm going to go over that a lot more before we have a quiz on that. If we have a memo quiz, I'll post it. Bye, girls.
Bye.
Good question.
What is our what?
Well, wait, those are the